Welcome to the lesson Principles of Fuel Cell Operation. In this lesson, we will discuss the fundamental principles of how fuel cells operate and generate electricity. Let's look at our lesson objectives. By the end of this lesson, you will be able to explain how galvanic cells convert chemical energy into electricity. Next, you will be able to describe the basic operation of a hydrogen fuel cell. Finally, you will be able to compare hydrogen fuel cells with batteries and internal combustion engines. What is a galvanic cell? A galvanic cell is a device that changes chemical energy into electrical energy. Think of it like a machine that converts the energy stored in chemicals into usable electricity. Every galvanic cell has three main parts: two electrodes called the anode and cathode, and a special substance called an electrolyte. Many devices you use every day, like batteries in your phone or flashlight, are galvanic cells. Fuel cells, which we'll learn about later, are also galvanic cells. The anode is one of the two electrodes in a galvanic cell, and it's called the negative electrode. At the anode, a chemical reaction occurs in which the material loses electrons. This process is called oxidation. When the anode loses electrons, those electrons don't just disappear. Instead, they pile up on the anode itself. Since electrons have a negative charge, this buildup makes the anode negatively charged. The anode wants to get rid of these extra electrons, which is important for making electricity flow. The cathode is the other electrode, and it's called the positive electrode. Unlike the anode, the cathode wants to gain electrons during a chemical reaction. This process is called reduction. The cathode attracts positively charged particles called cations. These positive particles, which gather at the cathode, give it an overall positive charge. Because the anode is negative and the cathode is positive, there's a difference in charge between them, which creates an electrical potential, like the two ends of a battery. What is an electrolyte? An electrolyte is a special material that sits between the anode and cathode. Its job is to let charged particles called ions move through it. Ions are atoms that have either lost electrons, making them positive, called cations, or gained electrons, making them negative, called anions. Here's the important part. The electrolyte lets ions pass, but doesn't let electrons pass. This is crucial because if electrons could travel through the electrolyte, the anode and cathode would be connected directly, and we couldn't capture any electrical energy. By blocking electrons while allowing ions to pass, the electrolyte forces electrons to travel along an external path where they can do useful work. Now let's see how all these parts work together to generate electricity. The anode releases electrons that can't travel through the electrolyte. Instead, these electrons must travel through an external circuit, that is, a wire connected to the outside of the cell. As electrons flow through this circuit, they can power something useful, like a light bulb or a motor. Eventually, the electrons reach the cathode. At the cathode, the electrons combine with the positive ions that traveled through the electrolyte from the anode. This completes the chemical reaction. The reaction continues, producing a steady flow of electricity until either the anode material is exhausted or we disconnect the circuit. What is a hydrogen fuel cell? A hydrogen fuel cell is a special type of galvanic cell that converts the chemical energy in fuel directly into electricity. Most fuel cells use hydrogen as fuel and oxygen from the air. Unlike burning fuel in an engine, a hydrogen fuel cell uses an electrochemical reaction to produce electricity without combustion. The hydrogen fuel cell produces two things: electricity to power devices and heat. Because there's no combustion, hydrogen fuel cells can be very clean and efficient at producing electricity. How does a hydrogen fuel cell function? In a hydrogen fuel cell, hydrogen gas is directed to the anode and oxygen from the air is directed to the cathode. These gases flow through channels on either side of the electrolyte, which keeps them separated. At the anode, hydrogen molecules split, releasing electrons. These electrons flow through an external circuit, creating electricity. Meanwhile, hydrogen ions, which are hydrogen atoms without their electrons, pass through the electrolyte to the cathode. At the cathode, the electrons, hydrogen ions, and oxygen combine to form water. This is why hydrogen fuel cells are so clean. The only byproduct when using pure hydrogen is water. This diagram illustrates the comparison between hydrogen fuel cells, batteries, and internal combustion engines. Now, let's understand these comparisons as we proceed through this lesson. This table compares hydrogen fuel cells, batteries, and internal combustion engines. Hydrogen fuel cells and batteries both use electrochemical reactions to generate electricity. However, hydrogen fuel cells receive hydrogen and oxygen from external sources and can continue producing electricity as long as fuel and air are supplied. Batteries store their chemical reactants inside the device and must be recharged once their stored energy is depleted. Hydrogen fuel cells generate electricity directly without combustion. Internal combustion engines operate differently by burning fuel at high temperatures to produce mechanical power. When pure hydrogen is used, fuel cells produce water and heat, resulting in no harmful tailpipe emissions. Batteries also produce zero tailpipe emissions during operation. Internal combustion engines can emit pollutants unless cleaner fuels and emission control systems are used. Battery electric vehicles rely on batteries, hydrogen fuel cell electric vehicles rely on fuel cells, and internal combustion engines remain the primary power source in gasoline, diesel, and some hydrogen-fueled vehicles. Hydrogen fuel cells can operate at low or high temperatures. Low-temperature fuel cells, such as proton exchange membrane (PEM) fuel cells, typically operate around 60-90 degrees Celsius and require specialized catalysts like platinum to speed up reactions. High-temperature fuel cells, such as solid oxide fuel cells (SOFCs), operate between about 600-1000 degrees Celsius and often do not require these expensive catalysts. Operating temperature affects how quickly a fuel cell starts, how fast reactions occur, and which materials are used to build the system. Let's look at the summary for our lesson, Principles of Fuel Cell Operation. A galvanic cell converts chemical energy into electrical energy using an anode, a cathode, and an electrolyte. Common examples include batteries and fuel cells. The anode is the negative electrode where oxidation occurs, meaning it loses electrons that then flow out of the cell. The cathode is the positive electrode where reduction occurs, meaning it gains electrons, creating a charge difference that drives electricity. The electrolyte allows ions to move between the electrodes but blocks electrons, forcing electrons to travel through an external circuit to do useful work. A hydrogen fuel cell is a type of galvanic cell that uses hydrogen and oxygen to produce electricity and heat, with water as the only byproduct when pure hydrogen is used. Thank you.